Hello everyone, I'm Jeslyn, and welcome back to the Devlog, where I build a 3D application for iPad. In the previous video, I talked about the overall vision for this project. A lot of people watched that video and left some really thoughtful comments. So I just want to take a moment to say thank you. It's genuinely motivating to see people interested in this project and curious about how it evolves. So, in this video, we are going to look at something more technical. We'll explore the core of the application and how the engine handles 3D objects. The app starts with a script called app.gd. This is where everything begins. The app class stores the main data, like the engine, the context, and the scene. The engine controls all operations, which I'll implement in later videos. The context stores the current state of the application, like a cache. And finally, the scene. The scene holds data like objects, collections, mesh curve data, and so on. To test things, I added a simple camera controller script. I added a basic cube. This script lets me rotate and zoom around the scene. Now, the first major step, displaying custom geometry. Let's start with something simple, a plane. It has 4 vertices, 4 edges, and 1 face. But here's the important part. Render engines doesn't use faces, they use triangles. So every shape, no matter how complex, needs to be converted into triangles. And those triangles must follow a consistent order based on face normal. Let's see an example. This is one of the interior scenes I worked before. We see each object individually and understand them. But this is how the render engine sees the scene. Render engine splits all objects into triangles so they can compute them before displaying on the screen. To handle this, I created a function called CalculateMesh. This function loops through every face and determines what kind of geometry it is, triangle, quad, or Ngon. If the geometry is already a triangle, we simply ensure the vertex order is clockwise based on face normal. If it's a quad, we split it into 2 triangles. First, we take the first 3 vertices as a triangle, then we form another triangle using the remaining vertex and its neighbor. But Ngon is where things get interesting. Ngon is a face with any number of vertices. To convert it into triangles, we need exactly number of vertices minus 2 triangles. For this, I used an algorithm called ear clipping. The idea is surprisingly simple. First, we project the 3D face into 2D to simplify calculations. Then we iterate through the vertices and try to form triangles. Here's an example. There are 8 vertices in total, so we loop through each vertices. First we choose vertex 0 and takes its neighbors 7 and 1. Now we have to check whether the angle is concave. Now we have to check any other vertex point is inside this triangle. If not, we will form a triangle in clockwise direction. If any vertex is inside the triangle, we skip the vertex and move to next one. And by continuing this method, we get triangles for a Ngon face. Some softwares like Blender uses more advanced method like beauty triangulation, which I might explore in a future devlog. Now the CalculateMesh is ready. So, let's test with some geometry. Here is the script to create a plane. To display the mesh in Godot scene, I created an object manager script, which takes mesh and create a mesh instance 3D using array mesh. Here is the script to create a circle to test triangulation. And that's it for this video. In the next one, I will start working on mesh editing tools and introduce more advanced algorithms. Thank you for watching. If you enjoyed the video, consider subscribing and leave a comment.